the table in my kitchen, back from a hiatus. Um, this is This Week in IP&O. Thanks for tuning in. We have special guest Matthew Peterson, who is a senior project director in IP&O. Matt, thanks for joining us.
Well, thank you very much. I appreciate the opportunity. Looking forward to doing this. As I said before, I've watched a couple of podcasts. First time I've been able to participate in it. And just one real quick note. The group that we're a part of, which is the Project Services Group within RBHS Newark, RBHS, is a diverse group of professionals that provide project management services to all the RBHS campuses in Newark and within Rutgers. So.
Cool. So we know that recently you've been working on a few projects, specifically with the cogeneration plants at Rutgers. For us and for everyone listening at home that doesn't know what cogeneration is, can you explain what that is?
Well, cogeneration, by the strict definition, is that you take one fuel supply and you produce two sources of power out of it, two sources of energy from them. In the case of the cogeneration systems within Rutgers, we actually have two cogeneration systems, one on the Busch campus and one at the RBHS Newark campus. So what we're doing is we use turbine generators. We have 3 turbine generators in each location that basically are fed with natural gas, in Busch's case with fuel oil, and we produce electricity from it, and then thermal energy at the back end of it. It's a very, very efficient process. So each one of the turbines in Newark has basically their 5.1 to 5.6 megawatts per turbine generator. So we're capable of producing like 15 megawatts of power, and we can produce up to 120,000 pounds of steam per hour out of the 3 turbines. So that's basically, so you're getting electricity and steam out of the turbine generator. So that's basically what cogeneration is.
So we heard that there's been some updates to the cogen plants, particularly on Busch and RBHS Newark. Can you tell us a little bit about those updates?
Well, originally the turbine generators that were in the locations, the 2 locations, the Busch cogeneration which was done by John Fritzen and Glenn Pettit, basically had a 5.1 megawatt, what's called a solar P60 turbine. The one in Newark had what was then a P50 turbine generator, which was at 3.8 megawatts. So all of the equipment related with the turbine generators were removed, taken out, and then the new pieces were put in. The older generators, the older turbines, used water to reduce the emissions from the turbine. So they would inject water into it and basically cool down the flame so you wouldn't provide as much nitrous oxide out of the exhaust. The new technology with solar turbines have what's called a Solenox burner in it, where there is no water being used for the injection. So as a result of that was updated. All the water treatment was taken out. In Newark, we had put in new gas compressors because we received gas at 15 pounds, and the turbines use 200-pound natural gas pressure. The heat recovery steam generator in Newark and the heat recovery boiler, hot water boiler in Busch were replaced, and both were installed with new booster burners or duct burners that would allow us to produce all of the steam that we needed or could out of the machine. In addition to that, in Newark, what we did was we replaced all of the high voltage main switchgear within the plant. So those are basically upgrades on that just as a note, the replacement of the turbines in Newark results in the savings of a couple million gallons a year of water. So it's those that plus the energy costs that you have, and it makes them quite viable. So that's what's been done with them. There's new stacks up in Newark, 115 feet tall, which was quite a thing to watch when they did that, because they had to take down the existing exhaust stacks and put these other ones up, and they actually put them in. And I had a bet with one of the contractors for a cup of coffee that they weren't going to go in exactly where they were supposed to. I lost the bet. These are like 8-foot diameter stacks, 115 feet. It came in 3 pieces, and they actually went down a set where they were supposed to be within a quarter of an inch.
Wow.
Would you be able to tell us about the importance of keeping the cogeneration plants up to date, especially considering the natural disasters and keeping the hospitals running?
Well, in the first place, what we're doing is we're producing electricity which is identical to the type of electricity that we buy from PSE&G. The turbine generator systems provide a redundancy for the hospitals and for the buildings on the campus. If PSE&G loses power, the turbine generators can provide that power up to their limitation, which is, like I said, about 16 megawatts. On a peak day in the summer, we utilize 20 megawatts, but we also would shed some of the buildings in order to do that. The other part of it is that we can operate as an island, which means that if PSE&G loses power, and we've actually had this happen, then the turbines continue to run and continue to provide power into the campus and leave everything continuously operating. In the other item, for example, the basis of this was done through the state of New Jersey through the NJEDA and the grant for that as a offspring of Hurricane Sandy. The damage that was done to the state. This went from NJEDA provide the funding to build redundancy, to build the system, and support the university hospital. And then we operate the plant through the power plant through Rutgers or the hospital. In addition to that, let me just take one little thing here, just to make sure. I have some notes here. We also provide emergency support in the immediate area if it's due to the ability of our ability to continuously provide the power and operate, and as well as supporting emergency management groups within Newark and in accordance with the state emergency management. That's where we actually are supporting everything, just like we would want to do under it's energy usage and removal and reduction of water.
Yeah, that's interesting. I feel like when it comes to that kind of stuff, just like energy and keeping buildings running, like a lot of people don't get all this that goes into it. I feel like they just kind of take it for granted that the power just goes on, but it's it's like a big collaboration between people like you and the people running the plants and maintaining it and keeping it up to date. So thanks for explaining all that to us and to everyone listening, because I'm sure a lot of other people didn't understand that either.
Well, I hope it sheds some light on how we do that, because the power plant is the heart of the campus. Okay, it provides steam heat, it provides cooling, it provides compressed air, and actually all the electricity is funneled through it. So that keeps everything operating. And if you lose it, then you're shutting down. You're not able to fulfill our requirements for our responsibility.
Mm-hmm.
Yeah.
I think you shed some light on it, literally and figuratively. Literally, you helped shed the light onto into the classroom. So thank you. Thank you again for coming on and for explaining that. And as we always do, we will give you the last word if there's anything else that you'd like to say.
Nothing other than the fact that I enjoyed this. It was an interesting new opportunity to speak out and pass on information to everybody. I've always enjoyed. I've worked many years with energy and projects, so this is a nice opportunity to pass that on to everybody. Hope it was informative.
Definitely.
Thank you.
Yeah, thanks, Matt, and thanks everyone for listening.